For this particular lesson, we're going to be discussing a rational function and rational expressions briefly. This is a good place to introduce this since we've just focused on factoring polynomials with higher degrees. Factoring is a very important process in simplifying rational expressions. So we're going to introduce to you what a rational expression is, and then how factoring plays a part in simplifying them. So if we look at this, a rational function, if we have an equal sign, is just simply two functions put in the form of a fraction. So you can see here we have one function on top and one function on bottom. And you can have any type of function in the numerator and the denominator, but when you put those two together, you're now dealing with what's called a rational function. Now, assuming there's no equal signs, what we're dealing with at that point is just a rational expression. So, same thing as a rational function, but without the equal sign. So we basically have a fraction, a numerator and a denominator, that have both a function in the top and in the bottom. Now, each of these function parts can represent any degree polynomial, and so that's where the factoring comes into place. So all of your factoring methods are going to be extremely important here. Now, we're going to focus in this first video on simplifying rational expressions, and you know that when we simplify something, we're just simply trying to break it down to its smallest parts. And there's basically two required steps for simplifying rational expressions. The whole objective with a rational expression is to eliminate common terms. So we're trying to eliminate common factors. Let me use correct terminology here. So we want to eliminate common factors. So if we are to factor both the top and the bottom, and there's anything in common, we want to cancel those out. And so you can see that that's the premise of these two steps to simplifying a rational expression. The first thing we're going to do is factor the numerator and then factor the denominator with all of the methods that we've learned. And then we're going to divide out any factors that are common to both the numerator and the denominator. And when we say divide out, it's just a mathematical way of saying that they're going to eliminate each other. We're going to cancel them out. So let's take a look at a simple example here. If we look at this little example that we've got a rational expression because we have a quadratic expression on top, and we have a quadratic expression on bottom. Now we want to factor both of these. So on the top we had to factor out a common monomial, and you can see that x was common in there, and so we had x plus 5 left over. And then of course we've done factor trees with x squared, so that gives us an x and an x. Now what we want to do is factor out the common factors. Again, that's an important term because you can see here that this x on top and one of these x's on bottom would cancel out, leaving us x plus 5 over x. Now, this is an extremely important concept that you need to make sure you understand. You can divide out common factors. That's what we did with the x and the x here. But you cannot divide out like terms. So in this particular situation, you cannot take out these x's. So these x's do not cancel. And so we're talking about that x and we're talking about that x. Those x's do not cancel out because on the top expression the x value is added to the 5, so that is one complete term together. So that whole term has to match up the term on the bottom of the fraction as well perfectly. You can't take a piece of that expression and cancel it out. So just be very careful that you're canceling out factors and you're not canceling out like terms. Now, if we look at this, we have an example down here, a little bit broader scope. So you can see example number 1, we have a trinomial and a binomial. They're both quadratic expressions. On the top, you just have some basic factoring, so that's basic factoring of a trinomial. On the on the denominator, you have a difference of squares. And so when we factor both the numerator and the denominator, they both end up having a like factor of x plus 2. So that factor, sorry about that. So basically we can see that the x plus 2's will cancel out. Looks like it's not going to cooperate. And so now, when our x plus 2's cancel out, we're left with x minus 2 over x, x minus 6 over x minus 2. Again, these x values cannot cancel out because they're part of a bigger term. So the like terms do not cancel out. So that is a quick introduction to simplifying rational expressions. Again, you realize factoring, all forms, extremely important. You need to know how to do common monomials, basic trinomials, perfect square trinomials, difference of squares, grouping, sum of cubes, difference of cubes. You have a long list of factoring methods that you must know to continue on in these further lessons. So take some time to look at that, and we'll do some practice problems in the next video.